I'm going to draw the picture and I'm going to use the same layout. Everything in black is what they'll give you and the blue stuff is what you will have to write down. Hi, can I please speak to Chef? Yeah, quickly. Okay. Oh, man, it's already so. Okay, guys, I'm just going to fill in the required to prove parts along because we're wanting to prove tan chord theorem. So we want to prove that this angle is equal to that one, right? That's what tan chord theorem states. So we want to prove that angle BAP is equal to angle C. Now the construction is similar to yesterday's one. Again, we are going to fill into radii so that we can use angle at center in this triangle here. So that is going to be the construction. Oh, here we go. So again, I'm just going to do it in a dotted line so that you can tell that that is the construction, but we're going to construct OA, which is a radius, and then we're going to construct OB, which is another radius. Okay, now what we're going to do is, just so that the proof is a bit easier to work with, we're going to make angle C equal to X. All right, so we're going to say let C equal X. So this angle is going to be X, and then we're going to kind of work our way towards that angle and prove that that one is also X. All right, but using other things, not tan chord theorem, using other theorems that we know, and then we can say that tan chord theorem is true from there. Okay, so we're going to start the proof by saying let angle C equal X. Now we're going to work our way towards angle BAP. So the first thing that we're going to say is that angle AOB is then 2x. All right, because of angle at center. So then AOB is equal to 2x. The reason there's angle at center equals 2 times angle at circumference. Is it raining, guys? A bit, yeah. Okay, AOB is 2x. We can fill that in if you want. Now, remember, we want to get this angle over here. So we're going to work our way towards that angle. We're going to find this angle in this isosceles triangle, right? When we constructed those radii, we actually also constructed an isosceles triangle over there. So this angle is 2x. The other two angles together will have to equal 180 minus 2x. And we're going to divide that by 2. Okay, so that's the next step. So OAB is equal to 180 minus 2x over 2. And if we simplify that, we're actually going to get 90 minus x. The reason for that, now we need to put those 3 reasons that we always do. All right, so we're going to say angle sum in triangle, angles up equal sides, and then radii as well. But guys, this whole angle, because now we have that one, hey, and we actually want this one over here. The whole angle, OAP, isn't that a 90-degree angle? Right, because of radius perpendicular to tangent. So that's the next step. So we're going to say OAP is equal to 90 radius perpendicular tangent or tangent perpendicular radius. I can't remember the order now. I actually think it's the other way around, but it doesn't matter actually. No, it's the same. Yeah, it means the same thing. Okay, so guys, if we have the whole angle, which is 90, and we know that that top part is 90 minus x, to get the angle that we're actually needing, we have to take the whole angle minus that one. All right, so we're going to say, therefore, angle BAP is equal to 90 degrees, the whole angle, minus 90 minus x, which is the top part of that angle, and we want the bottom part. Remember, when you're subtracting more than one thing, more than one term rather, sorry, you have to put them in brackets, okay? We have to say 90, that was the whole angle, minus 90 minus x. And what is this going to give me? What's 90 minus 90? 0. And negative times a negative is positive. All right, so it's actually going to give me x. Sorry, Fayaz, do you want to say that? Yeah, and there we have it. Right, because we said that C was X, and now we've shown that BAP is also X. Let's just finish it off by actually saying what was required to prove. Okay, that always has to be like the last line. So therefore, we now have proven that BAP is equal to C. Now guys, the proof in the notes, which is on Google Classroom, that document 7, that has all the, obviously now, all the opposite angles of cyclic, all the cyclic quad stuff, sorry, and all the tangent stuff. The diagram is just wrong. So the proof is fine, but on this picture, they put the X over there. All right, where it should actually be there. So if you are looking at this, rather just, yeah, I mean, that X mustn't be there. Sorry, the diagram was just copied from last year's notes, and I didn't realize that it had the X in the wrong place. Okay, so, but you have the correct diagram here. You make that angle equal to X, and then you work your way backwards. You could work from this X going to the other side as well. It would also work, all right? But yeah, this is just the way that I always do it. It's also the actual proof that's in the notes, but then it has a different diagram. Okay, sorry about that. So how do we feel about these proofs, guys? I don't think they're too bad, hey, Shanwa? Here we go. They are, I think, quite easy to understand. It's just that you are going to have to do some memorization. You are actually going to have to remember how you must start it, basically. You must remember the construction, and then you must remember the starting point of the proof. Yes. Yes, it does usually look like that one. The only thing that they change quite often is the letters. Okay, so I wouldn't memorize this proof verbatim. I mean, you can, but they might give you like a PQR instead of a, well, then that wouldn't be P, but they might give you different letters, okay, or STU. So you obviously then wouldn't be able to say let angle C equal X if there's no C on the diagram. Okay, so you do need to be able to, what's the word, adjust the proof based on the letters that they're giving you. Yes. No, they won't. So you have to, so they'll give you the proof in words, and you must then translate it to say that was an S and this was a T and that was a U. You will then have to fill in the required to prove is angle S equals that angle there. All right, TUP, whatever. Sometimes they give you the required to prove, but not always. Okay, so don't necessarily expect that. Okay, guys, you were supposed to do number 6. It was quite tough, hey? Some of the questions were quite tough. Okay, so I'm just going to finish that off quickly. I want you to work on number 7, which is also quite tough. You'll see that it is an 8-mark question. It's one question. They've given you a diagram. They're saying, These two lines are tangents. O is the center of the circle. Angle C is X. Prove that O2 minus A is 180 degrees. Okay, it's just a one question thing. That's what it looks like. I'll keep it on the board for you. So guys, if you get a question like this will be like the final question in the test. All right, the problem solving one, the really difficult one. It's 8 marks. We try to not make it 8 marks because that's a bit hectic, but maybe a 5 or possibly a 6-mark question where you just, guys, what I would suggest, just calculate whatever you can. All right, so if you've seen that C is X, and obviously O1 is going to be 2X. Write that down. Okay, it might not be relevant to the final proof, but you might be able to use it. And if it is something that is on the memo, you'll get a mark for it. 1, maybe 2 more. Okay, so I would suggest just try and find as much stuff as possible. So, ooh, that was weird. That gave me a bit of a fright. Okay, let me just freeze this. So the first thing that I would write down is that O1 is 2X. So, 10 on here. Well, I haven't done this one either, hey? So I'm not sure how to go about this. I would say O1 is 2X, and what I'm saying to it, what do we know here? We know that these two are equal, right? Tangents from common point. Write it down, you might use it somewhere. What else? What else do you know? Yeah, this will be 2X. Radii equal, yes. So this is also a kite, okay? That side helps us. What are they asking us to do here? Prove that O2. Now we know what O2 is, right? So that's good. We have that part. Minus angle A is equal to 180 degrees. So that's what I am thinking. We need to find A, obviously, right? We have to say 360 minus 2x minus whatever A is. So what I would try and do here is try and prove that this is a cyclic quad. Right? You can actually do that. And then once you've proven that it's a cyclic quad, that is going to be 180 minus 2x. Okay, and then you'll have it from there. Because if this is a cyclic quad, then you have that opposite angles are supplementary. So first prove that that is a cyclic quad. Obviously, you find this as well, all right? Prove that this is cyclic quad, and then this will be 180 minus 2x. Then you have your A, and then you can literally work that out. And you can say O2 minus A. 360 minus 2x minus 180 minus 2x is equal to, and it will give you 1. Okay, Robert? Angle sum and quad, yes, you could, if you have those two. Yeah, you could do angle sum and quad, yes. Okay, I've kind of done it for you now. You just need to figure out how to write it down properly. Okay, and how to prove that it's a cyclic quad. I told you how to do that, yes. Don't say it. Right, don't spoil it for people. Okay. It's just the revolution activity. Yes, it's the same one, it's just the very next question. So number 6 is up there. Okay, I'm quickly going to do number 6. And then we can talk about that one. Also took me forever just to draw the actual picture. Yes. It's revolution or angles around a point. Those are the two reasons. Yeah. Okay, guys, sorry that diagram is very busy. I told everything as I was working. So just for 6.1, in order to prove that the whole shape was a cyclic quad, you had to actually do condition 3, the third way of proving that something is a cyclic quad, where you show that a chord subtends equal angles. All right. Now, if they're asking us to prove that ADCB is a cyclic quad, then we're going to use CD as if it's a chord. All right. We're going to approach it as if CD is a chord. And then that means that if this chord subtends the same angle there and over there, That means that it's a chord, so these 2 points have to lie on the circumference. That point has to lie on the circumference, and that point has to lie on the circumference of a circle that obviously isn't drawn in, all right? But if that is true, then that means that we could draw a circle through those 4 points. Okay, so what you had to prove that was, because they told us that A1 is X, we had to prove that B1 was also X. Right now, there were also multiple steps to that, so it was quite difficult. Did we notice that D1 is X because of tan chord theorem? Right, that was the first thing that you had to see. So D1 is equal to X because it's an angle between the tangent and chord DG. And chord DG then subtends that angle there. So those two angles are equal. So D1 is equal to X tan chord theorem. Then, be with you now, if we're looking at this triangle here, right, it is obviously an isosceles triangle, this big triangle on the side. They told us that those two sides are equal. So if that angle is X, then that angle is also going to be X because of angles opposite equal sides. Right, and there you have that A1 and B1 are equal. So you have a chord subtending the same angle at 2 points, meaning that the chord and the 2 points are on the circumference. Okay, the chord is not on the circumference, but the points making up that chord. So therefore, it is a cyclic quad, and then you're going to say converse angles in same segment. Okay, that is the more difficult one of the 3 ways of proving that something is a cyclic quad. Sometimes you can wangle it, and you can actually find information that so that you could use one of the other 2 methods. But in this case, it was the shortest way of doing it. Yeah, that is the one that's often forgotten. So guys, something that is important. You might not have been able in 6.1 to prove that it's a cyclic quad, but the question said, prove that ADCB is a cyclic quad, meaning that even if you can't prove it, if you don't know how to do this, you must then still in the next or in the following questions use the knowledge that even though you couldn't prove it, this is now a cyclic quad. Okay, so you can use those properties of a cyclic quad because you actually had to do that in the next question in 6.2. Okay, so that's why they set it up as prove that questions. So that even if you can't prove it, you can still use that information going forward. Right, so for 6.2, they wanted you to prove that AC, which is this line, bisects BAD, which is that angle over there. Now we knew that that was X, so basically we have to prove that that is also X, all right? Or that the whole angle is 2X, because if you have 2X and that is X, then obviously the other part is going to be X. So now what I did was, I saw that, okay, I have this triangle. I have X and X, so the third angle in that triangle is going to be 180 minus 2X, right? Angle sum in triangle. You don't have to write the name there. I just wrote it so that you can follow what I'm doing. So 180 minus 2X. Now, guys, remember, this is now a cyclic quad. I'll be with you guys now. Did I make a mistake? Why do you have so many hands up? Okay. This is a cyclic quad. Remember, even if you couldn't prove it, you must now use properties of a cyclic quad. So that means that angle C and angle A are opposite angles of the cyclic quad. So if that is 180 minus 2X, that one has to be 2X because of opposite angles of a cyclic quad. They have to add up to 180 degrees. And 180 minus 2X plus 2X is 180. Okay, so that is how I got that A is 2X. The whole angle A is 2X because of opposite angles of cyclic quad ADCB. Even if you couldn't prove it here, you can use the fact that it's a cyclic quad in 6.2. They told you that it is. All right. So now, guys, if I have that A1 is X, but A, the whole angle is 2X, then that means that A2 has to be X as well, right? Because X plus X will give you 2X. So I just wrote that in. You didn't really have to write that, I don't think. Okay, it's enough to say that A is 2X. But then you have to just end off with what they've asked you to prove. Okay, so just please add the AP bisects the AP. Go on.
I said converse angle in
A2 is equal to D1. Oh, there, yes. Okay, it's not converse angles, it's just angles in same segment. Yes. Good. I didn't even notice that. Okay, that's perfect. I can add that there. That's a good one. Right. Well done if you saw that, guys. That's again using now the fact that this is a cyclic chord. We can now use that as a chord. And we have that D1 is X. So then A2 will also have to be X. Nice. Well done. All right. So A2 is equal to X. Angles in same segment. Therefore, AC bisect BAD. Cool, that was then just a one-liner. Nice. BAD. Is that what the rest of you also going to say? Lisa?
Or can you say A2 equal to X equal chords?
Equal chords, equal angles. Yes, good. Yes, you could have done that as well. Well done. All right, so you also could have said, because you have this chord here, subtending X, and you have that chord there, which is equal to this one. So that one also has to subtend X. Good. So another option here would have been equal chords. I'm just going to use that because I'm running out of space. There you go. Nice on the face, guys. Any other things that you saw there? Yes. So I had to prove this later on. That's what I'm given. No, so I only prove that in the next one. Yes. We can talk about this. One is X, yes. So that's that option. So they both tended by forward BC. Okay, well done, guys. You came up with better options than mine. Okay, 6.3, they asked for, they wanted us to prove that DG is equal to FG. So there were other ways yesterday, some other people were saying, okay, we can prove that this top triangle is congruent to that triangle using angle, side, that's fine. Just a bit longer. And also took me quite a while to notice this, but we actually had to use, to do it in one step, we had to use the converse of equal chords, equal angles. Because in the actual circle now, with two chords that we can see immediately, they are chords. FG is subtending an angle X, and DG is also subtending an angle X. So that means that these two chords have to be equal. We know that if equal chords, if you have equal chords like what we said here now, with DG and DG, those will subtend equal angles, but it works the other way around as well. If you have two chords that are subtending the same angles, then that means that those chords will be equal. So the reason there is then just swapped around. Here we said equal chords, equal angles. Here you would have to say equal angles, equal chords. Okay, and it's because of those two angles that are equal. A1 is equal to A2. Comment? Yes, that's fine. Could have done that. So you probably would have used what angle, side, and what angle, right? You just check, it's just angle, side. Angle, side. Yeah. Yes.
Angle A1 subtending
Mm-hmm.
So A2 subtending.
Yeah, so it's basically this. Right? Because those two angles are equal and they're subtended by the chords have to be equal as well. Yes. So that is the reason that you have to write down. Okay. Yes. What is that enough? Enough to prove that it's a type. I think you would have to. I'm actually not sure about that. I feel like it might not be enough information to prove that it's a type. It is a type. But I think you might have to add, just think about that. Okay. I see what you're saying, and it definitely is a kite, but maybe you would have to also say that these two angles, because this is angle in semicircle, that's angle in semicircle. Maybe you would have to say that they are also equal, because then that's more information of how that line is actually cutting the whole thing off. I think I'll just double check that. Okay. All right, any other options, guys? Okay, it's looking good so far. 6.4, they wanted you to, what was this one? Determine with reasons the size of C2. Yes. For this one, for 6.4. 6.3, angle in semicircle to say that that's 90 and that's 90, yeah, and then? Yeah, so you could use right angle, hypotenuse, but then you need another side. So then you would have to know that these sides are also equal. Not necessarily. Yeah, but you would have to state that. So you would have to prove that. So at the moment, all we know is that it bisects this angle. We don't know that it actually bisects everything else. Okay, because this, yeah, I mean, it does. You just need to say some more. Okay. 6.4, we were asked to find C2. Now, guys, again, I use the fact that this big shape is a cyclic quad because D2, if we look at angle in semicircle there, D2 is 90, right? Are we fine with that? But if we're looking at the whole cyclic quad, D2 is actually not only subtended by AG, but also by AB, right? Do we see that? In the whole big cyclic quad, AB subtends D2, and AB then also subtends C2. All right, so because of angles in same segment, if that one is 90, C2 also has to be 90. Okay, so you have to do this in two steps. First, you have to say that D2 is 90 degrees because of angle in semicircle there. And then because D2 is also subtended by the whole chord AB there at the top, it will be equal to the other angle subtended by AB, which is C2. All right, so you can see there I wrote D2 is equal to 90, angle in semicircle. Therefore, C2 is also equal to 90, angles in same segment. And I just added here, just so that you know, you remember where that comes from. It's from chord AB. Any questions on that one? All right, 6.5, they were asking you to prove that G1 is equal to O2. So I just thought, okay, let's quickly see if we can actually find those angles. O2 is this angle at the center, right? It's subtended by FG. FG subtends an angle of X at the circumference. So does it make sense that O2 is then 2X, right? Because of angle at center, sorry, because of that reason. So that's what I said there. O2 is equal to 2X. Angle at center equals 2 times angle at circumference. Then I looked at this cyclic quad, which we actually haven't used a lot or at all, really. The obvious cyclic quad, all right, the one that is drawn with all 4 points on the circumference. We haven't actually worked with that one as a cyclic quad. But do we agree that no, sorry, I'm looking at the wrong thing. G1 is an exterior angle of this cyclic quad, right? Because it's one of the sides lengthened, and then it's the angle at the outside, right? So G1 is actually an exterior angle of this cyclic quad, right? And then G1, the exterior angle is supposed to be equal to the opposite interior angle. Now the angle next to it is that angle there, and the opposite angle is then 2x. Okay, so G1 is equal to 2x, that whole angle A, because it is an exterior angle of that cyclic quad, the one that's in the circle. Yes. G3. Yeah. Yes. Because of this one here. Yes, that's fine. And then what did you do after that to get this? Okay. Yes, angles on a straight line. Yeah, that's fine. That also would have worked. Yes.
Can you explain the first thing?
Equal to 2x because of a2, which is equal to x. Oh, sorry. Because of a2 is x. Right? a2. So this whole angle is 2x, but a2, that smaller angle there, is just equal to x. And a2 is subtended by FG at the circumference. And then O2 is subtended by FG at the center. Okay, so because of angle at center, that's how I got that 2x. Then I said G1 is equal to 2x because of exterior angle of a cyclic quad. So then if they're both equal to 2x, they are equal to each other. Yes. Okay. Mm-hmm. Yes. Yeah. Okay, in semicircle, yes, that's fine. Mm-hmm.
And then O2 equals to 180 degrees
Minus those ones, yeah. Mm-hmm.
angles on the triangle.
Yes.
And then G1 equals 180 minus 99.
So did you have G5? Okay. Yes. Yeah, that's fine. Okay, does it make sense what I did though? Do you see that you could have done it in, wait, where were we there? In like a one line. Okay, guys, it's fine if you do longer methods as long as you get to the same thing. It's just, it's better obviously to be able to recognize the shorter ones because it will save you some time. But yeah, it's fine. If you have the time and you get it, that's fine. Okay, our time is up now, actually. Yeah, it's 10:29. So on Monday, we will mark the rest of question 6, so 6.6, 6.7, and then question 7 as well. And then, guys, we are starting with trig on Monday. I know it's a bit silly because it's the day before your test. All right, but we've done loads of practice on circle geometry. We can't really afford to delay trig by another day, okay, because trig is quite a big section and we don't have a lot of time for it. So we are starting trig on Monday, and then Tuesday you do your test, and then Wednesday we're carrying on with trig. Okay, but we will mark this stuff on Monday as well. 6.6 and 6.7 especially were really interesting questions, so we definitely will talk about those.